Hi, this is Tom, and in this video, we're going to look at the domain of a rational expression. So a few things need to be done. First off, we need to know what a rational expression is, and to know that, we need to know what a polynomial is. Well, you've already been working with them, but here's just an intuitive explanation. A polynomial, if I could spell correctly. A polynomial is a sum of a number and x's and x squareds, and you could even have x cubes. You can have as many as you want. We call it x to some counting number xn. Okay, so that's what a polynomial is, and we've actually been factoring we've been factoring quadratics, which are polynomials with x squared, an x, and a number. Now, a rational expression, and I'm going to use this abbreviation RE. A rational expression is a fraction of polynomials. Is a fraction of polynomials. So before we take a look at rational expressions, let's review fractions. So, for example, if I give you a fraction of 2/4, let's write it this way. In all fractions, you want to write them as simply as you can. So we'd say simplify. If I give you a fraction like 2/4, most of us are comfortable understanding that that's the same as writing 1/2. So 2/4 simplifies to 1/2. Here's another example. How about, here's a sneaky one. How about 0/3? Well, this just means something is cut into 3 equal sizes, of which 0 are available. So you'd say this is just 0. Finally, we're going to try one more example. And what happens if we switch the 0 and the 3? So we have 3/0. When you do this, the result is what we call, when 0 is in the denominator, we say that the fraction is undefined. It's not even a number. It doesn't make sense. So we just simply say 3/0, or 3 divided by 0, is undefined. And I would encourage you to check in your calculator. Check in calculator. What happens when you take 0 and you divide it by 3, and 3 divided by 0? The calculator will often give you something like invalid entry or error or some kind of message like that. And that's the way your calculator tells you something's undefined. Okay, so then the question is rational expressions. Well, a rational expression is a fraction. So that means that it's a rational expression in some cases can be undefined. And what we want to do today is find all possible numbers that the rational expression, where the rational expression exists. And we do that, the easiest way to do that is by finding out where it does not exist. So, new word. The domain is the set of all possible numbers. Of all possible numbers. So, what we're going to do is take a look at the domains for some rational expressions. So here's our first one. So let's try this. I'll write it like this. Consider the rational expression of x divided by x minus 1. And the question is can this be undefined? For example, let's do this. Let's try. What happens when x is 0? Well, that would mean I'd take 0, 0 minus 1. Well, this is going to give me 0 over negative 1. But we already just found out that when 0 is in the numerator, that's just 0. So x can be 0. Let's try another one. For example, what about, try x equals negative 1. All right, so if we do that, then I'm going to have a negative 1 divided by a negative 1 minus 1. Well, that's going to give me a negative 1 over negative 2. That's just 1/2. Okay, so that works. So and when you look at it, most numbers do work. Meaning that you can put the numbers in and you'll get some fraction or decimal out. So most numbers work. So when does the denominator equal 0? And it's the answer to that question that we need to find. And we do that very simply by just setting the denominator, which in this case is x minus 1, equal to 0, and solve for x. So let's see, I'm going to add 1 to both sides. And my result is x equals 1. So let's just see what happens then. So if I put x equals 1 back into my rational expression, I have 1 divided by 1 minus 1, but this is 1 over 0, but we just said that is undefined. So here's what we do now. We say the domain for a rational expression of x over x minus 1 is any real number except x cannot equal 1. There is another way of writing this, and it's a mathematical way of that whole sentence. That whole sentence can also be written in what we call set builder notation. And set builder notation is written like this. You use this left curly bracket, and then you say x, because that's the variable. There could be a different variable, but this variable is about x. Then you write this vertical line, which is read as such that x is not 1. And that's how you could write the domain for the rational expression of x divided by x minus 1. Okay, let's try one more example. So, example. Let's find the domain of, and the rational expression in this one is 2 over 2x minus, 2x squared minus 5x plus 2. Okay, well here's the thing. It doesn't matter what number goes into the numerator. Just like in the last problem, the numerator can be 0. That's okay because that just makes the fraction 0. What can't happen is 0 in the denominator. So what we need to do is find out when is the denominator two x squared minus 5x plus 2 equals 0. That's what we have to figure out. But wait a minute. We've just finished doing that kind of solving that kind of a problem. And if you recall, what we did is we first played the game. In the top position, we took the first number, we took the 2 times the number without any x's. So we went 2 times 2. And in the bottom position, we take the number in front of the x. And so when we do that, we have 2 times 2, we get a 4, and the negative 5. We need two numbers that multiply to positive 4 and add to negative 5. And I'm coming up with minus 4 times minus 1. Yeah, that works. So now we rewrite our quadratic. So rewrite using answers to the game. Answers from game. And we get 2x squared minus 4x minus 1x plus 2 equals 0. Okay, now we can factor by grouping. Factor by grouping. So if I do that, it looks like, now remember, there's no greatest common factor in this problem. However, if you break this into groups, we can have what we call common factors. So common factor in the first group is, it looks like we have a 2x. And in the second group, there has to be some common factor. I think we're going to try common factor is negative 1. Okay, so let's try this. 2x, so that's going to factor out to an x minus 2. Then I'm factoring a negative 1, so remember to include the sign. And then I have left, I have an x, and then it changes the sign on the positive 2 to a negative. And look at this, now we have a greatest common factor in the problem of x minus 2. So I can write this as x minus 2 times 2x minus 1 equals 0. And then, remember, we set each factor to 0. Each factor to 0. So we have, this is going to give me x minus 2 equals 0, or 2x minus 1 equals 0. So add 2 to both sides for this first one. So this is going to be x equals 2. And here I'm going to have to, we'll add 1. So now I have 2x equals 1. Divide both sides by 2, so I have x equals 1/2. So we would write our domain as we'd say the domain. You could write a sentence, the domain is any real number except x cannot equal, we have 1/2 and 2. And in set builder notation, we write curly bracket x such that x, oops, except that x cannot equal, sorry, not equal 1/2, comma, 2, curly bracket, and we're done. And that is how you find the domain for a rational expression. Remember, the key is the numerator doesn't matter at all in the problem, only the denominator. This is Tom. Thanks for watching.